So hey guys, welcome back to the channel. This is a physics buddy. In today's class, we'll be talking about another topic from forces and motion, which is friction. We'll talk about all the types of friction, how it acts, what are the different types of friction acts on what condition. Apart from this, we have already covered different units on honors physics curriculum already on the channel. Do check them out. And if you like the video, subscribe to the channel and do comment what topic you want me to cover next. When we start something new, it takes time. So you have to devote time in order to understand something valuable. Although time is money, and this is not something which you can get for free.
All right. So let us just try to understand what is friction now,
Mhm.
how friction will act, how its value will change, and so on. So in order to understand friction, first of all, we need to understand that this is again one such external force which might act on the particle or the system to affect its relative motion. Now, what friction is? Friction is an external force, which affects the relative motion between two surfaces. Now, this affect means it may you can say it may oppose the motion or it may support the motion. So you won't say that it always affect the motion in negative way, that it always oppose the motion, but sometimes it also supports the motion. That is what we need to understand here about friction. Let me just give you an example to make you understand each and every part of friction. So suppose there is a car and somehow this car is out of fuel. So what we have to do here is we have to push this car through some distance so that it reaches gas station. How we can do that? So just try to understand how forces are acting here. So what happens here is that you find that your car is out of fuel, so you thought of pushing it to the nearest gas station. And while you were pushing it, you are actually applying some force, right?
Mhm.
Now just think about it. Whatever force you have applied, that force is supposed to be external force. But because of the surface, if I assume this surface is rough, this surface wants this car to stay at its initial position. Why? Because it wants to oppose the relative motion most of the time. What we can say here is it wants to oppose the relative motion. So in place of this, you can also mention that it wants to oppose the relative motion. Friction is a force which generally opposes the relative motion. So because of the external force, friction will act in the backward direction to oppose the motion caused by this external force. So what happens here is from the surface only, from the surface of contact or whatever point of contact we have, a frictional force might act. So let us try to understand it with another example. As of now, just keep this point in mind. Like friction acts always in such a way that it opposes the relative motion, like the direction of friction I'm talking about. Just try to imagine another one such example. This is quite interesting and this will make you understand each and every type of frictions we are having. Friction is not something which is of only one type, it is of two, three types. Let us understand each type. So I'm taking a very simple example to make you understand all these things. So just imagine there is a small kid who was playing with a coin, found that his coin somehow went beneath the almirah
Mhm.
and it reaches still here. So this is its coin. What he tries to pull this almirah away by applying some external force. But in return, he found that he is incapable of moving this almirah. So he went to his elder brother asking for his help. So his elder brother came. Now they both tried to apply the external force, but still they are incapable of moving this almirah. So why they are not capable of moving this almirah? Think and tell me.
Mhm.
Like what is the reason that they are not able to move this almirah alone? Both of them also.
Their
What do you
applied force isn't
there's what?
I guess their combined applied force isn't great enough to move the mass. Like it's too
That was not great enough to move that mass. That's why this almirah didn't move or it didn't move from its place.
yeah.
Like the question you need to understand first. So I'm saying that they both are, when they are applying force together also, they are incapable of moving this particular huge mass. So what is the specific reason? Why they're not able to move this? Because friction don't want this system to get displaced from its location. Like for example, friction will always act in such a way that it will oppose the change in its motion, or you can say change in its position. It
Right.
always wants that the object moves in such a way that it will stay in equilibrium. So if an object is moving in the forward direction, friction must be acting in the backward direction. So if we are applying some external force towards right, so automatically there will be a force of friction which will act towards left, and this force of friction will oppose the relative motion. This force of friction will oppose the relative motion. Now let us understand what will happen to its magnitude. So assume that initially the boy was the only one who was applying force, and initially he applied a force of 100 newtons as per his capabilities. He applied external force of 100 newtons. Similarly, when his elder brother came, he also applied a force of 300 newtons. This is what I am assuming as of now to make you understand the values of friction. So when kid was applying force alone, when he was applying force alone, friction force, how much friction force must be active? Friction force of same magnitude, 100 newton, was acting at that point. So initially, when the boy was applying 100 newtons force, the friction force at that time is also 100 newtons. This is what we need to understand. In the second case, when kid and his elder brother applying force, so if they both are applying force together, so what should be the friction force at that stage? I'm assuming again the mass isn't moved from its position.
That would be at
So I would,
least 400 then.
yeah, so it should be at least 400 newtons of force, friction force, which was acting. Some of these two. So what we need to understand here is that till the moment, or till the time when object is not moving. So till the time when object is not moving, friction must be equals to external force. So till the time if the object is not moving, friction must be equals to external force and is called static friction.
Mm.
So we need to understand this fact that if we are unable to move an object, so there must be some force acting in the opposite direction of external force, which is supposed to be called static friction. And this value of static friction is the only value of force which is auto-adjustable in nature. Auto-adjustable in nature means whatever external force is acting on the system, friction will act in such a way that it will keep on increasing its value until it reaches its maximum value. For example, there's a graph between frictional force and applied force. So suppose this x-axis is representing applied force and this is representing frictional force. So initially we assume we are increasing the applied force. So as we are increasing the applied force, friction force will also increase this way. But there comes a point where the value of friction force is no more capable of increasing its value. So if we increase the applied force as well at this point of time, friction force will become constant. So we need to understand from this particular graph that how many types of friction forces are there. So when there is a straight line, when friction force and applied force are directly proportional to each other, the force of friction is known as static friction. Whereas there appears a point at what static friction has its maximum value. Like what is the maximum value that can act in a system? That maximum value is known as limiting friction. Or this limiting friction can also be written as maximum value of static friction. So you need to understand all these parts, that how friction is acting and how these things are making differences. And once the object is in motion, at that point of time also there must be some friction acting, which friction is known as kinetic friction.
Mm.
So in this particular example, if suppose they both are incapable of moving the block initially, but finally what happens is that they ask their father to come and help them out. So what the father does is he applied a force, and assuming that all of them when applied force together, they are capable of moving the system. And I'm assuming that all of them were applying a force of 700 newtons. So if they are capable of moving a block of mass of a certain mass with an external force of 700 newtons, this means that we can say that we are capable of moving the whole system. So at that point of time, the friction which must be acting It is supposed to be kinetic friction. What you need to understand here is that the friction force is something which is directly proportional to the normal reaction. Whatever type of friction is this. A friction force is something which is directly proportional to the normal reaction. Like for example, if there is a block of certain mass,
Mm-hmm.
assuming it must be experiencing mg in the downward direction, so the normal must be acting from the surface like that.
Mm-hmm.
And if somehow we applied some external force in the forward direction, because of that external force due to the surface, friction must be acting in backward direction like that. Assuming some external force is acting in the forward direction. So what we found here is that this frictional force is directly proportional to this normal
Mm-hmm.
like that. When we remove this proportionality, we got a constant called coefficient of friction, which is represented by mu.
Mm-hmm.
This friction is of two types, as I told you, majorly.
Wait, what's mu
Static.
again?
Mu is coefficient of friction.
Oh, okay, okay.
This coefficient of friction is generally of two types based upon the type of friction. If it is a static friction, what is the condition of static friction to act? Object must be at rest.
Mm-hmm.
Similarly, it can be of second other type, which is called kinetic friction. What is the condition for kinetic friction to act? Object must be in motion. Static means object must be at rest. Kinetic means object must be in motion. So if the object must be at rest, they must be acting static friction, and we can represent it as Fs, which is equals to mu Sn, where mu s is coefficient of static friction, whereas Fk is represented by mu Kn, where mu n is kinetic friction, coefficient of kinetic friction.
Mm-hmm.
Similarly, if we talk about this mu s, we can say coefficient of static friction.
Mm-hmm.
So these are the things that you have to understand. Now again, we just need to make sure that coefficient of static friction and coefficient of kinetic friction will be used when we actually understood that what is the state of object. In most of the states, you will observe that object is at rest, or in some states it might be moving. So how everything is going to happen, let us understand using one problem, and that problem is based upon the second one only. I'm taking the same configuration, I'm taking the whole system to be experiencing friction due to this surface which is in contact. So I'm assuming this is my M1, this is my M2, and this time this surface is rough, having some value mu, it's given, let's say. So question is again same, find acceleration and tension. You should try it out once, see if you can do it. Again, remember the surface is rough, so there must be some another force friction which must be acting on the block M1.
Yeah.
So think about it, that how you can do it. And again, start with drawing FVD only. FVD is the most important part of solving these problems. If you are able to draw the FVD well, you are able to solve it easily. Otherwise, there will
Okay.
be a
So we don't know the weight of the masses though.
what?
The
I
weight.
haven't given. I didn't give you the value of mass. You can consider it in the form of variables only, M1 and M2. That's it.
Oh, okay.
First of all, draw the FVD, then see how forces are acting. Use the second equation of motion to solve to form the equation of force.
So second
Do it
equation, can
step
you
by
say
step.
T minus mu M1 times G equals M1 times A?
Yeah, correct.
Okay.
Nice. Do it once, then I'll solve it. We'll get to know if there is anything missing. All of the equations you form is correct.
All right. Okay, so for acceleration, I got A equals M2 minus mu M1 times G whole divided by M1 plus M2.
M2 minus mu M1.
Yeah. So that's in parentheses. So parentheses M2 minus mu M1 close parentheses times G whole divided by M1 plus M2.
That's correct. Nice.
Okay. And then for tension, I substituted in acceleration. So it becomes T equals M1 times M2G times 1 plus mu whole divided by M1 plus M2.
That's also correct. Nice.
Okay.
So you got, I guess, how to solve these questions, and that's pretty fine. You need to understand that whatever force is acting, we have to find out the net force. If you are able to find out the net force easily, you'll be able to solve it. For example, let me give you another question. Suppose this is a block of mass 20 kgs. The coefficient of friction's value is 0.25. Let's say it is given here. We are applying a force of 100 newtons on this block of mass 20 kg. You have to find its acceleration. Try this one out.
Okay. Okay. I got this wrong, but I got acceleration equals 2.5 meters per second squared.
Let's check it out.
Okay.
So first of all, you need to understand that how forces are acting. So if it's 100 newton in the forward direction, so there must be some friction acting in the backward direction.
Right.
So F net must be equals to ma. Net force is going to be 100 minus F, which is equals to 20 times A. So 100 minus F, F is going to be mu n is going to be mg, which is 20 times A. So 100 minus 0.25 times 20, I'm assuming g as 10, is equals to 20A. So 200 times 0.25, which is supposed to be 50 newtons, is equals to 20 times A. So A is going to be 50 over 20, which is supposed to be 2.5 meters per second square, and this is our correct answer, which is the correct one. So this is how you're supposed to find out the value of forces,
Okay.
or you can say acceleration as well. So let's go ahead with the last question, which you showed me through the notes. Now again, you have to apply the same process. Mass is m1, this mass is m2, but the question suggests this m1 is supposed to be 10 kgs, whereas this m2 is supposed to be 15 kgs. I
Right.
found out the acceleration and tension of the system. Write out and tell me.
Okay. So this one incorporates trig though, right?
You don't need to remember any tricks, just try to form the equation for each and every block, and you can have tension and acceleration. Just try forming the equation.
Okay.
So when you are supposed to take the next class now?
Oh, tomorrow works or does it work for you? 5 p.m. tomorrow?
Tomorrow 5 p.m.
Or hold on, let me see. We don't need to take it tomorrow if it doesn't work for you, but I just have trials. That's why I just suggested to cancel it for now, but um I said maybe
Like
5 p.m.
by for 5 p.m. it will work for you, right?
Yeah.
All right, it will work for me as well. We can have it at 5, no issues.
Oh, okay.
Yeah, so we'll have tomorrow at 5, and on Sunday if it's possible for you to take, just let me know tomorrow as well.
All right.
As of now, try to draw the ability of both the masses. So just need to understand that how forces are acting. First of all, tell me in which direction the two blocks will move.
They'll move in, I guess, downward for M2 and then upward for M1.
Exactly. Whereas if you just mark the forces, it will look like that. Now what you have to do is you have to form the equation of second law of motion equation. So it is going to be t minus 100 is equals to 10a, and it is going to be 150 minus t is equals to 15. What you have to do is just solve these two equations using elimination or substitution, whichever method you feels like. It is going to be this. If we eliminate and add these two equations, we'll get 50 is equals to 25. The acceleration must be equals to 2 meters per second square. We got the acceleration. We can substitute the value of acceleration back in one of these two equations, and we can get the value of tension as well. Also, using first equation, I can say T must be equal to 10 times 2 plus 100, which is supposed to be 20 plus 100, that is 120 newtons. It's not like that you can only substitute the value of A in the first equation to get the value of tension. You can also do the same by putting the value of A in the second equation. So when we put the value in the second equation, we get T must be equals to 150 minus 15A, which is 15 times 2. So 115 minus 30, again it is coming out to be 120 newtons. So whichever equation you feels like you should use, you can use. Answer from both the equations must be the same. Again, in almost 80 to 90% questions, you'll be applying that particular relation, which is supposed to be known as F times MA. So keep this point in mind, and if anything like that is there, just let me know. I hope you understand all the concepts well, and this is how you're supposed to form the equation and find out the required variable. Is this clear?
Yeah, got it.
All right, then let's keep it till here only. See you tomorrow at 5 p.m. PST. And till the time, make sure you try all the questions which are there in the assignment or PDF given by your class teacher. And if you have any problem and any doubt in any question, just let me know.
Okay. All right.
All right, then. See you tomorrow at 5.
See you.
Bye. Take care.